Hello everyone, this is RayPCB, your trusted PCB partner. Today, we will introduce how to associate components with packages in Kicad and how to import 3D models. After creating the component library and the PCB footprint library, the next step is to link the schematic components to their corresponding packages. Today, we continue to use the LED model SM400, 10304, and 8, which we've already drawn, as an example to demonstrate how to associate its component library with the footprint library and import its 3D model. First, let's open up the component library once again and take a look inside. Select our custom library and this component. After opening the component, we select the component properties. In the component properties, we click Edit. After clicking, click on Footprint. A symbol will appear next to Footprint. Click this symbol to open the footprint library information. We select our custom library and a component under our custom library, and then we will see the footprint we drew in the previous session. Click OK, then click OK again to complete the association. You can also see that a mark for the associated library appears here. Then click Save. So the association between the component and the footprint is now complete. It's very simple. Next, let's talk about how to import a 3D model. Why do we need to import a 3D model? Let's first get a direct hands-on experience. Here's a PCB with a 3D model. After I finish drawing the PCB, I can observe it in 3D model mode. This makes it very convenient for me to check whether the position of each component is appropriate, whether there is any component interference, and I can also combine it with the enclosure to determine if the height of these components fits properly inside the case. So being able to import 3D models is extremely useful for design. Now, let's take a look at how to import a 3D model. First, we need to open the footprint editor and select the component we want to import. So how do we import it? First, we need to have a 3D model. Where do we get this 3D model from? There are two ways. The first way is to create it yourself. If you know how to do 3D modeling, you can use 3D modeling software along with the datasheet to redraw it yourself. The second method is to download one, because many models have already been open source online, so we can just download them. The website I often use to download models is this one. If we search for our component here, unfortunately we find that no one has created and shared a 3D model for our component, but we can also certainly try other alternative methods. First of all, we already know that our primary component is a 0.3-inch LED digital tube, so let's try searching with a slightly different keyword, specifically the term LED digital tube end. Then carefully observe what valuable information comes up. Look, now we find that many people have shared different LED digital tubes. We can look for ones that have the same package and suitable dimensions as ours, which involves a selection process. For example, ones like this with pins arranged on both sides are more in line with our requirements. Let's just click on one and take a look. It will then load its model. Oh, this model is different from ours. That's okay. Let's just take a quick look. I'll show you how to download it. First, check the information provided is width and height. Remember, our width is 7.6 and the height is 12.7. So if the dimensions don't match ours, we shouldn't download this one. Below, there are also many different models and sizes this person has shared quite a lot. Even though it's not suitable, let's say I'm not going to download from here, but I'll show you how to download from this website. If we find one that's suitable, how do we download it? We need to select the file format here. Kicad supports importing stat files, so we usually choose a higher version. If your Kicad is relatively new, you can select the highest version step AP243 or AP242, then click on this format and hit download. It will download a compressed file, and after you open the archive, just export a step file and you're good to go. Next, let's see how we can import this 3D model. Assuming you've already found a suitable one, I already have one here that fits, which I drew myself. Then click on Package Edit, click Add, then open the file. Here I already have a model in step format that I drew myself. Click Open, and you'll see, hey, the 3D model has appeared. Once it's loaded, in order to view it accurately within the overall 3D structure later, we need to adjust its position. As you can see, its height isn't quite right either. And the position is also off, so we need to make some adjustments. The left-to-right direction. This left-to-right direction is the y-axis. The up-down direction is the left-right direction is the x-axis. The up-down direction is the y-axis, and the height direction is the z-axis. We won't change the scale factor. It's already appropriate. Actually, having a scale factor is also beneficial, because even if the model you download isn't a perfect fit, you can adjust it to the right size by changing the scale, so it's more versatile. This is for rotation. Our current orientation is just right. The angle and position are correct, so there's no need to rotate. We can also quickly check what rotating in each direction looks like. This is a 90-degree rotation around the x-axis, and this is a 90-degree rotation around the y-axis. The y-axis rotates in this direction. This is a 90-degree rotation around Z. Since ours is already properly aligned, we don't need to rotate it. Now, for the offset, we do need to make some adjustments. Let's take a look first. If we view it from this side, we can see more accurately. So, first, this direction is the y-axis, and this is the x-axis. Let's adjust it by 1 millimeter first, and see which way it moves. Oh, I see that 1 millimeter is a bit too much, so let's reduce it. Let's say 0.6 millimeters now. At 0.6 millimeters, I think the position is just right in the middle. As for the y-axis, we actually don't need to adjust it. Sometimes the y-axis needs to be adjusted too, so let's see what happens if we adjust the y-axis. Adjusting the y-axis will move it up and down. But in our case, the y-axis is just right, so we won't touch it. The y-axis is correct. Now, what about the height? We also need to adjust it just like in actual soldering, so that the edge is just touching the PCB. This way will be more accurate when judging height interference in the future. So, for height, this direction is usually negative. Let's try minus 1 millimeter first. It moved down by 1 millimeter. Now I feel like what's left is less than a millimeter, so I'll subtract another 0.5 minus 0.5. Still a bit too high. Increasing by 0.5 at a time is a bit much, so let's adjust it manually by 0.17. 0.17. I think this height is already very suitable. Now let's click Save, and then click Save again. This way, after we place this component and generate the PCB, we'll have a suitable 3D model available for use. That's all for today's content. If you enjoyed this video, please subscribe to my channel for more videos. Thank you everyone.